Hello friends, welcome to my channel Molgen Tech. Please subscribe my channel, share my channel, like my channel and press the bell icon. So in this new video, we are today discussing the ionization of strong acids and bases, ionization of conjugate acid and conjugate base. We are also going to see some values like Ka, Kb, Kw, pH, pOH, and what is the relation between Ka, Kb and Kw. So keep listening the video, don't skip the contents. Ionization of strong acids and bases. So a strong acid is a substance that ionizes almost 100% in aqueous solution. So if you see inorganic acid like hydrochloric acid, sulfuric acid, nitric acid, so these acids, when you dissolve in water or in aqueous solution, it ionizes 100%. And when it is ionizing, a proton is transferred to water molecule, so it will become a hydronium ion and a chlorine ion. So mostly it is a proton is transferred to water molecule to become H2O, a water, to become a conjugate acid. So otherwise you can also put it like HCl ionizes to hydrogen ion and chloride ion. Similarly, the ionization happens with the strong bases also, like potassium hydroxide, sodium hydroxide, like strong bases. Once it dissolve in aqueous solution, it ionizes to potassium ion or sodium ion and hydroxyl ions. So in the case of ionization of strong acids and bases, even at a very low concentration, it ionizes 100% in aqueous solution. So acids and bases based on Bronsted concept. A molecule which is donating a proton or hydrogen ion is considered as an acid. A molecule which is accepting a proton or hydrogen ion is considered as a base. So in Bronsted concept of acids and bases, a molecule which is donating a proton or hydrogen ion to a base is considered as Bronsted acid, and after donating, that Bronsted acid will become conjugate base. So a conjugate acid, when it donates a proton to a conjugate base, then the conjugate base become a conjugate acid, and the one which is donating, that is conjugate acid, will become conjugate base. So conjugate acid donate proton and become conjugate base, and a conjugate base accepting proton or hydrogen ion will become a conjugate acid. So if you see a reaction between conjugate acid and conjugate base, you can see a pair of conjugate acid and a conjugate base. So before going to see how the ionization of weak acid happens in water or ionization of a weak base happens in water, we will see first how ionization of water itself will happen, because the water molecule itself can undergo ionization. So the ionization of water, or you can put it in two ways. One is like a simple dissociation. Water, you know, it's H2O, so it will dissociate into hydrogen ion and hydroxyl ions. Another is The water molecule you can consider as a conjugate acid and conjugate base. So two water molecules will be taking part in ionization. So one hydronium ion and a hydroxyl ion will be produced. So in this two way you can represent ionization of water. So in one case it is a simple dissociation. So dissociation value you can calculate like concentration of hydrogen ion into concentration of hydroxyl ion and divided by concentration of water molecule. And the Ki, that is ionization constant, according to Bronsted acid Bronsted base concept or conjugate acid conjugate base concept, concentration of hydronium ion into concentration of hydroxyl ions divided by concentration of two molecules of concentration of water molecule in square, because there are two molecules of water is taking part. So in the earlier slide you saw that the dissociation of the ionization of water molecule you can represent in two ways. One is just a dissociation of H2O into hydrogen ion and OH, or there will be two water molecules. So one water molecule will be transferring hydrogen ion to the second molecule, so there will be hydronium ion formation. So in these two ways you can represent ionization of water. So in one case it is dissociation and another one it is ionization based on Bronsted and acid base concept. So you know 1 mole of hydrogen ion, when it is formed, 1 mole of hydroxyl ions will be formed. So the water, when you see, the neutral pH is 7. So at neutral pH is the one where the hydrogen ion concentration will be equal to hydroxyl ion concentration. So at neutral pH 7, there will be 10 to the power minus 7 molar of hydrogen ion will be there, and similarly 10 to the power minus 7 molar hydroxyl ion also will be present. So when you take 1 liter of water, according to the molecular weight of water, there will be 55.6 molar water will be there. So when you compare this, the ionization concentration is very low. So when you want to calculate the Kd value, so the concentration of hydrogen ion is 10 to the power minus 7 and the hydroxyl ion is 10 to the power minus 7, and when you take the water concentration, you can neglect the number of hydrogen ion formed from 55.6 because that is the larger value. Similarly for the Ki calculation also you can consider like that. So you can calculate the Kd value as 1.8 into 10 to the power minus 16 and the Ki value like 3.24 into 10 to the power minus 18. So in the last slide we saw that the dissociation constant is 1.8 into 10 to the power minus 16 and the ionization constant is 3.24 into 10 to the power minus 18. So if you see the aqueous solution, whether you are adding potassium hydroxide or sodium hydroxide or any weak base or whatever it is, when or water itself, if it is without any acid or base, the molarity of water is going to be constant, whether it, throughout the ionization. So because of that, the dissociation constant can be multiplied by the molarity of water, and the ionization constant can be multiplied by the water the concentration of the water involved in the reaction. So if you multiply it, you will get a value that is called a specific constant of water, that is Kw, that is 1 into 10 to the power minus 14, which is a multiplication of concentration of hydrogen ion and concentration of hydroxyl ions. Similarly, if you multiply the ionization constant with the concentration of the water involved in the reaction. There also you will get the specific constant of water like 1 into 10 to the power minus 14, which is actually the multiplication of the concentration of hydronium ion and hydroxyl ion. So here we defined three values, that is Kd, Ka and Kw of water. When the water is ionizing, you can calculate these three constant values, which will be used for calculating the values like pKa, pKb, pH, pOH, etc. like that. So keep watching my video. Please subscribe my channel. Also share, like my channel, Molgen Tech. So next in this what we are going to see is earlier we saw that the product of hydrogen ion and hydroxyl ion concentration is equal to specific constant of water. So from this we can make another relation, that is pH plus pOH is equal to 14. So you take the log of this expression, that is log hydrogen ion concentration plus log hydroxyl ion concentration is equal to log of Kw. You multiply all with minus sign. So negative logarithm of hydrogen ion concentration, negative logarithm of hydroxyl ion concentration, and negative logarithm of Kw. So you already have seen in videos that the negative logarithm of hydrogen ion concentration is equal to pH, negative logarithm of hydroxyl ion concentration is equal to pOH. So and the negative logarithm of Kw is pKw. So pH plus pOH is equal to pKw, and if you take this value, you already know the Kw value is 1 into 10 to the power minus 14. So if you take the log, it is 14. So pH plus pOH is equal to 14. So what is the relationship between Ka and Kb for weak acids and bases? So a weak acid, when it ionizes in water, it becomes a hydronium ion and a conjugate base. Okay, so you can calculate the dissociation constant or ionization constant, like concentration of hydronium ion and concentration of the conjugate base divided by concentration of the weak acid. Similarly, for a weak base when it hydrolyzes in water, it becomes a conjugate acid and a hydroxyl ion. So there the dissociation constant or ionization constant you can calculate like concentration of HCl or concentration of conjugate acid into concentration of hydroxyl ion divided by the concentration of the conjugate base, or you can say concentration of the weak base. So here the hydronium ion concentration you can calculate like this: concentration of weak acid into Ka divided by the concentration of conjugate base. Similarly, for a weak base you can calculate like or hydroxyl ion you can calculate like this. So if you see the multiplication of like you saw in the last slide, if you see the specific constant of water is a multiplication of a proton and hydroxyl ion. So in most of the cases the hydronium ion also is taken as a proton ion or H plus like that. So product of H plus ion into the concentration of H plus ion into concentration of hydroxyl ion is the specific constant of water, Kw. So if you multiply this with this, you can see that Ka into Kb is equal to the specific constant of water. Or if you take log and derive it, you can get it like pKa plus like you saw in the last slide. If you take log K, log B, log W, and if you multiply by minus sign, and if you take it, you will get like a pKa plus pKb is equal to 14. So if you take a weak acid will be having an ionization constant like Ka, okay, and for a weak base there will be the ionization constant like a Kb. Weak acid, you can say formic acid, acetic acid, like organic acids, or sometimes it is also known as protic acid, like that, because it will be donating a proton. Okay, and Kb is like a weak bases. Okay, so if you take an amino acid, you can see there will be a weak base, you can say amino group. Okay, so if any amino group is there, you can use Kb, which is a weak base, like that. So if you take an amino acid, you know, there will be a carboxyl group will be there and an amino group will be there. So such kind of molecule, there will be pKa value and pKb value, both will be there. So this we will discuss later when we discuss about preparation of buffer and all. So any biological molecule, when it dissolves in an aqueous solution like DNA or protein or any metabolites, when it dissolves in water, it ionizes. So its solubility, the pH changes. So all this depends on this ionization constant and like that. So that is why this kind of constant values are important. So for any organic acid or organic base, there will be a value like Ka and Kb, and depending on that only you can prepare buffers or make a buffer system, or you can adjust the pH and all. So this is the relation pKa plus pKb is equal to 14. That is why when there is a carboxyl group and amino group is present, it will be neutral. Okay, and when it ionizes, depending on the pKa value and pKb value of the amino acid, there will be a change in pH will be there when it dissolves in aqueous solution. So that we will see later in when we discuss about the preparation of buffer, like that. So when a weak acid is added to water also, it won't ionize completely in the initial stage. So how you can calculate pH of weak acid before its ionization? So if you see, like the earlier equation you saw, that the ionization constant is equal to concentration of hydrogen ion, or you can say a conjugate acid, conjugate base divided by concentration of the weak acid. So in the initial stage, what will happen is the concentration of hydrogen ion remains unchanged. So it will be, or you can say the concentration of conjugate base, so that will be unchanged. So the degree of ionization will be so small that it almost remains unchanged. So because of that, like we have seen in the earlier slides, two water molecules interaction for hydronium ion and hydroxyl, like that. So here two molecules of the hydrogen ion, so it will become H plus square. Okay, and because here the conjugate base is not formed and it remains unchanged, so here also the concentration will be similar to the conjugate acid, so it becomes H plus square. There will be two hydrogen atom molecules divided by the concentration of the weak acid. So if you want to calculate the concentration of the hydrogen ion, it will be square root of Ka into concentration of weak acid. So like in the earlier problems, you take logarithms and multiply by negative sign. So you will get a expression which is pH is equal to pKa plus P concentration of weak acid divided by half. So similarly for a weak base also, you can see that it will be OH square here. Okay, OH square here. So if you want to calculate the concentration of the hydroxyl ion concentration, it will be square root of the Kb into concentration of the conjugate base. So POH is equal to pKb plus P concentration of conjugate base divided by half. So this is how the initial, so when a weak acid is added to water, it will not be, or weak base when it is added to water, it will not ionize 100%, or it will not ionize immediately, it will be slowly ionizing. So in the initial stage, so otherwise there should be some agent to ionize it fast. So in the initial stage, it will be almost unchanged. So in that case, this is the way you have to calculate the pH of a weak acid or pOH of a weak base. So we'll be discussing more details about this ionization in the coming videos also. So keep listening to our video, subscribe our channel, like our channel, and encourage us by asking comments. So your comments are very valuable for us, so that we can improve our contents, and we know what is the other requirements needed from our audience. So we will be posting more contents in our channel. So keep listening, and keep subscribing our channel, and share our channel, like our channel. Thank you very much.